All right, let's take a look at this problem and see if you got these things right. So first of all, it says, what's the domain? The domain is, I do what I call a vertical line scan. So I'm starting at negative infinity all the way over here. Is that going to touch the graph way over there?
No.
It is.
Or eventually.
It is eventually.
Yeah.
So yes, that touches it. Yes, 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 yes. Is there anywhere where it's not going to touch the graph? No. So all real numbers, that is correct. Good job. The next thing I do is to find the range. I'll do this in orange. I do a horizontal line scan. And again, the reason I'm doing this is because if I draw a horizontal line and it touches the graph somewhere, that means that there's some point that has -8 as the y value, and the x value would be there, -6, -8. So I'm scanning because I'm trying to see where there are y values associated with this particular graph. And as you can see, when you scan it, notice you can touch it in two places for a horizontal line scan. It's still a function. It's just not a one-to-one function, if you know what those are. Notice that, am I ever not going to touch the graph?
No.
No. So this is also correct, all real numbers. The next question is, when is it increasing and decreasing? Let me go back and re-explain the domain and range thing. If there was an open circle right here, let's say, then the domain would not include that value right there. That value would not be included because when you drew a vertical line in, it wouldn't touch a point on there.
Okay.
And so you'd have to exclude that x value, and then you'd have to exclude this value from the range, -2.
Right.
So those are the instances. There's one example that's called a whole removable discontinuity. There's another instant when there's a vertical asymptote or horizontal asymptote. So like if your graph did something like this, let's say that there was a line right here, you actually wouldn't see the line drawn in, but there was like something like this.
Okay.
Where there's a vertical asymptote, then that particular line wouldn't be part of the graph. Everything else would be, but just not that value, that x value, where that line goes through, whatever that x value is right here. Again, I'm assuming that this is, you don't see this. You don't actually see the line in here, but you'll see sometimes graphs that look like that. Okay, so that's domain and range. Now, when you talk about increasing and decreasing, that's really a matter of jumping on the graph and imagining from left to right, is it going up or is it going down? So when I jump on the graph over here to the left and I go over here, that's increasing that entire period. So from negative infinity to -4, it's increasing. And then again from that point to there, it's increasing left to right, because as I go from left to right, the y values get bigger. You follow?
Yeah.
And from here to the right, it's increasing. So all of those values would be where it's increasing. Let's see if you did that right. Yep, that looks right. And then it's decreasing. It's decreasing in the other segments. It doesn't only have to be increasing or decreasing. It could be constant, right? But these happen to be decreasing because from left to right, those regions, those two regions are, from when I go from the left to the right, the y values are getting smaller.
Okay.
Does that follow? Does that make sense?
Yes.
So that would be decreasing value. So it's from -4 to -3, correct? And from 1 to 2, correct. Good. Now, sometimes you'll also see where there's constant. So if there was like a point somewhere in here where there was like the line just like that, then it's not increasing or decreasing on that interval. It's constant on that interval. So sometimes you'll see that as well. Max and min, the max just means, and I think they mean absolute maximums, or do they mean relative?
Absolute.
No, it looks like they mean relative, yeah. Relative max and min is usually what they mean. So this is a relative max because it changes from increasing to decreasing. And then this is a relative min because it changes from decreasing to increasing. That's a relative max, that's a relative min. There's no absolute max or min. anywhere. So let's see if you got those right. The max is
So there could be
y value of -4. Y value of -4 at x equals -4. And then there's another one.
Yeah.
Y value of 3 at x equals 1. So you could also say 3 at -1. Actually, no. Y value of 3 at x is -1. So the point would be -1, 3. So that would be another relative maximum. Make sense?
Yep.
And then the minimums would be, here's your minimum. It's -3, -4. So there's one of them. And your other one would be here, which is 2, 2. So actually this is wrong.
Okay.
Right? It should be -3, -4. I'm sorry. -4. They're kind of having you write it backward. A y value of -4 at the x value of -3. Or was it a -5? Oh, you were right. It was -5. I looked at it wrong. It's -5. This point is -5. So you were right. -3, -5. So that's one of them. -5 at -3, and the other one is 2 at 2. So there's actually 2 of those. Continuity, that just means do you ever have to pick up your pencil when you're drawing it? And if you don't, then it's continuous. If there's like a hole somewhere or an asymptote somewhere, and if you had to pick up your pencil to draw it, then it would not be continuous. Symmetry, actually looks like there is some symmetry here. It's not symmetric about it's actually symmetric about this point right in between here and here, which is what, -3 and 1. So it's symmetric about this point right here. It's symmetric about that point, because if you flip it, if you think of that as the origin, and if it would have been symmetric about the origin. So technically there is symmetry about the point -1, -1. But I don't know that they want that. I think they may, since you wrote neither here, I think they may be asking, is it symmetric about either axis or the origin? Maybe, I don't know. But technically that is symmetric. Can you see how it can you see the symmetry there?
Yeah, because if you go up and then
like
X
this,
and then Y axis.
right, this is moving, this is 2 by 2 there, this is 2 by 2 here, this is 4 by 8, this is 4 by 8 here. So those are actually the same parabola, that just one of them is flipped upside down and this line is symmetric. So technically there is some symmetry there. I don't know if they wanted you to write that or not. Concavity, concave up and down, is basically where the tricky part to this is you haven't really learned calculus, some rules of calculus, so I don't know if he wants the exact value, but you can see that there's concavity here.
Right.
So that section is where it's concave. From there to there, -infinity to -3, it's concave down. And from here to there, you can see to infinity. So from 1 to infinity, it's concave up. Is that what you did? Yep, that looks good. And again, sometimes you can't tell the exact point because sometimes you just don't have the tools quite yet. I think they want you to kind of rough estimate sometimes. In this case, we didn't have to estimate. We can see what it is. X and Y intercepts. There's your X intercept there. About a half, yep. And there's your Y-intercept at 1. Yep, good. End behavior, as X goes to infinity, from the right it goes up to positive infinity and goes down to negative infinity. Good, perfect.